Before I get into the various steps, let me take a moment to talk about HTTPS and how we use it to secure web traffic. Now, we've talked a bit about the difference between HTTP and HTTPS. Remember that HTTPS is supposed to be the secure version of HTTP. And by secure, we really mean that it's encrypted. Encryption is essentially a process that scrambles the data so that eavesdroppers can't understand it. In order to best understand what's going on here, let's take a little deeper look. Chances are you've seen this before, and it probably won't be the last time you see it. This chart represents the various layers in something called the ISO OSI 7-layer model. Basically, this high-level chart shows the 7 different protocol layers that are really the backbone of everything we do on the internet. There are protocols that operate at the various layers, and each one has a special purpose. Generally speaking, when your computer is going to send information over the internet, it packages the data up using a protocol at the top layer. Then, the data from that protocol gets stuffed into the protocol just below it, and so on. That means that, within the data link layer, the data from the network, transport, session, presentation, and application layers are all present. Once the data is all packaged up at the data link layer, it's ready to be sent over the physical portion of the network, which is the physical layer down at the bottom. I'll explain this in more detail in a moment. For now, keep in mind that when we use HTTPS to protect information, it encrypts the information at these top 3 layers. Now, if a hacker can use a special program called a packet sniffer to monitor the network traffic, they'll see the information the way it looks down here at the data link layer. So, when we use HTTPS to encrypt information, that data will appear scrambled to the hacker. A sniffer looks at the data link layer. Each layer from 4 down has all of the layers above it encapsulated or stuffed into it. So, the sniffer sees the data link layer. The data at that layer has all of the data from the layers above encapsulated in it. Here's another version of that chart. It shows you which protocols are used at the various layers. We often refer to this as the protocol stack. You can see that Internet Protocol, or IP, is used at the network layer. IP's job is to ensure that your data gets to the correct computer. TCP is used at the transport layer, and its job is to make sure that your data gets to the right service or application on the other computer. That's why TCP and UDP use port numbers. Each network service listening on a computer associates itself with a specific port number. So, we typically send email to TCP port 25 and HTTP traffic to TCP port 80. The top 3 layers, session, presentation, and application, are a little murkier. We tend to treat all 3 of them as the same thing, which we generically refer to as the application layer. So, typically, the session, presentation, and application layer information gets placed into one of the transport layer protocols, such as TCP or UDP. When this happens, we say that the data is encapsulated. The transport layer protocol data then gets encapsulated into the network layer protocol, which is usually IP. The network layer protocol information is then encapsulated in the data link layer. The data link layer protocols are things like Ethernet and 802.11, which is what Wi-Fi uses. Again, when the data is all packaged up at the data link layer, it's ready to be sent over the physical medium. In other words, the network cable, or in the case of Wi-Fi, an antenna. So, let's follow the process. When a web server sends our web browser things like HTTP responses, HTML files, image files, cookies, and that sort of thing, it's sending us session, presentation, and application layer data. Again, we usually treat these 3 layers the same because the boundaries can be pretty murky. So let's just call it data for now. This data gets passed down through the protocol stack. First, it gets passed to the Transport Control Protocol, or TCP, which operates at the transport layer. TCP adds a header, which is basically just some metadata, to the front of the response data. Among other things, it includes the port number on our computer that the web server is sending the data to. Then the data gets passed down to the Internet Protocol, or IP, which operates at the network layer. All of the TCP data, including the original data and the TCP header information, gets treated as data by IP. IP then adds another header to the data. This header includes, among other things, the IP address of our computer. All of that data gets passed down to the data link layer. The protocol operating at the data link layer, which is usually going to be Ethernet or 802.11, adds another header to the front of the data and a footer to the end of the data. The header and footer together frame the data, so we usually refer to the data as frame data. The frame header contains, among other things, the hardware or MAC address of the next hop on the network, which is probably going to be a router. You can see how the original data gets passed down through the protocol stack, with each protocol adding some metadata along the way. The web server then sends the whole thing via one of its network interfaces, which is usually an Ethernet or possibly a Wi-Fi card. The various network routers along the way will peel off and replace the frame header and footer in order to get the data to the next router along the way. Ultimately, the data gets to our computer and the entire process happens in reverse, culminating in our web browser displaying the information. Here's the same process with HTTPS. HTTPS is basically just a way of encrypting all of that original data before it gets passed down to the transport layer. The web server will send the various HTML files, image files, and other information to something called TLS, which stands for Transport Layer Security. Now, we sometimes use the term SSL, but SSL is technically different. TLS and SSL work similarly, but TLS is more modern and much more secure. They basically do the same job, but SSL doesn't do it well enough to provide reliable security these days, so it's on the way out, and TLS is here to stay for now. So TLS will encrypt the data, and then the data will be passed down to the transport layer, just like before. From there, the same process is followed. TCP data gets encapsulated in IP, and then IP data gets encapsulated at the data link layer. Our original data is in the same place, but this time it's encrypted. Now, the TCP header, IP header, frame header, and frame footer are not encrypted, but that's basically all just metadata. At this point, the web server will send the whole thing through one of its network interfaces, just as before. Now, you've probably heard the term packet sniffer or maybe the term network sniffer before. Usually, when people use the terms packet sniffer or network sniffer, they're referring to a packet analyzer program like Wireshark. Most modern packet analyzer programs work with the operating system's packet capture facility to read network traffic and show it to the person using the packet analyzer program. In other words, someone can use one of these programs to see the data going over the network. These packet analyzers, or packet sniffers, get a copy of the network traffic at the data link layer. In the case of HTTPS, someone using a packet analyzer program will be able to see all of the data represented at the data link layer. However, the data that was encrypted by TLS will appear scrambled, which ultimately protects the confidentiality of that data. So, sniffing traffic associated with an HTTPS connection yields encrypted session, presentation, and application layer data. That's why we use HTTPS for sensitive data in web applications.